All right, for problem number 6 and 7, you're asked to evaluate each expression. And to do that, we are substituting in these values here, 2 for P, -3 for Q, and 0 for R. So P is 2, that'd be 2 squared, and that was being multiplied by Q to the second power, or Q squared. So Q is -3 squared, negative. 2 squared is 4, -3 squared is 9, and 4 times 9 is 36. Over here we got P to the power of Q, and Q being multiplied by Q to the power of P. So again, substitute 2 for P. Q is -3. It's multiplied by Q to the power of P. So Q is -3 to the power of P. Well, that's squared too. All right, now what to do here? Well, we've got this, again, negative exponent right here to the power of -3. So we're going to move this below deck, as I like to say, but down in the denominator. We'll leave this up top, -3 squared. 2 to the -3rd becomes 2 to the +3rd power, or 2 cubed, when we move it into the denominator. So we have -3 squared, that's 9, equals. So -3 squared is 9. We move this down into the denominator, 2 cubed is 8. So I accepted 9/8, or this reduces. 8 goes into 9 once with a remainder of 1. Keep your units. The denominator is 8. The next set of problems, actually 8 through 15, have to do with simplifying. So we need to recall some rules for exponents. When you have a power to a power, like the power of 2 to the power of 3, we have to remember that we multiply these. So we have 2 times 3, which is 6. So you have 2 to the 6th power, and 2 to the 6th power is 64. It's 2 factored 6 times. And then number 9, we have 2 multiplied by d squared multiplied by d cubed. Here you need to remember that when you have the same base, here it's d, different powers, we have 2 and 3, we just add those together. So we're going to keep the 2. We have basically what we called before when we did our polynomials was like terms, d. They're being multiplied, so we just add their powers, the exponents. Okay, and the easiest way, if you needed to think about that, well, how do I remember that? Well, d squared would look like d times d. D cubed, remember it's d squared times d cubed. So d squared is d times d, and that was being multiplied by d cubed, which looks like d times d times d. In other words, d to the 5th power. All right, over here, q cubed times r to the 4th power. These are not like terms, so we're going to just leave them alone. Again, we have powers being raised to powers, so we multiply, just like we did up in problem number 8. So we have to multiply the cubed by 4, so we get q to the 12th. And r, which has a power, it's understood to be 1. So 1 times 4 is 4. So it's r to the 4th power. And then on the last problem here, we have w to the 5th divided by w to the 2nd power. When you're dividing, and we just subtract exponents when they have the same base number. In this case, it's w. So 5 minus 2 is 3, w to the 3rd power. I always approach it that I'm going to start with the larger number. So I started with 5 and subtract the 2. That leaves me 3. And I started in the numerator, so that's where I'll end up. Some people, if for instance, it works nicely when you have a problem like this. If it had been reversed like that, then I would have started down below, and then 5 minus 2 leaves me 3. I would just put a 1 up there to hold that place. Some people I know have done with a problem like that. Oops. They will do something like this. W to the second, W to the fifth. They write W squared. I do 2 minus 5. 2 minus 5 is negative 3. And then they apply the rules for negative exponents, which is to move them down. So it would move down into the denominator like that and become positive. But you can avoid going through that process if you just start wherever the largest quantity of exponents for that particular number or variable are. Just start in that position. If you're in the numerator, stay in the numerator. If you're in the denominator, stay in the denominator. And number 12, same thing. Oh, well, that's just what I that's just what I was going over. Again, you can approach this either. All right, they have the same base, so keep your base. 2 minus 5 is negative 3, and then that simply moves down like that, so you have positive. Or when you look at this problem, just start where the larger exponents, we have more w's being factored here in the denominator, so start there. 5 minus 2 is 3. And it was in the denominator. There's none left up in the numerator. 1 will hold the place. And we're done.